Hello dear students, welcome back. We are starting a new topic for O levels, inequalities. First of all, we need to learn what inequalities are. Let us start with a small example. Let us start with a small example. As we know that 2 is less than 5. 2 is less than 5. So we write it as 2 is less than 5. If I add 2 on both sides, 2 plus 2 is less than 5 plus 2. This will give 4 is less than 7. Is this true? Yes, this is true. It means that we can add same number on both sides of the inequality. Similarly, 2 is less than 5. If I subtract 2, 2 minus 2 is less than 5 minus 2 implies 0 is less than 3, which is again true. It means we can subtract the same number from both sides of any inequality. Let us move further. 2 is less than 5. I am multiplying with minus 2, with 2, with the positive number. 2 into 2 is less than 5 into 2. It means 4 is less than 10. Is this true? Yes, this is true. It means we can multiply both sides of any inequality with a positive number too. Now let us multiply with negative number. 2 is less than 5. So what I am doing? I am multiplying with minus 2 on both sides. 5 is less than multiplied by minus 2. This will be minus 4 is less than minus 10. Dear student, is this true? No, this is false. Rather, it is minus 10 is less than minus 4. Yes, this is true. So, conclusion can be drawn that if we are given an inequality, we can add any positive number on both sides, inequality will remain the same. We can subtract any positive number from both sides, the inequality will remain same. We can multiply any number on both sides, inequality will remain same. But when we multiply any negative number on either both sides, the inequality will be reversed. It will be changed. It will be reversed. Less than sign will become greater than sign. Greater than sign will become less than sign. So these are the operations which we can perform to solve any inequality. What do we mean by solving an inequality? Let us relate it with solution of an equation in one variable first. A solution of inequality in two variables will be discussed in later lessons. X plus 5 is equal to 8, and if I say solve this equation, then I am asking you to give me the value of x. We have already learned in previous classes 8 minus 5x is equal to 3. So it gives us a value which satisfies this equation. X is equal to 3. When we put this value in this equation, both sides become equal. Likewise, what we mean by solving an inequality. For example, I say x plus 2 is less than 4. By solving this solution of inequality, we will perform the operation as we discussed over here. X is less than 4 minus 2. X is less than 2. So this is the solution of inequality which gives us value or values of x. In case of equation, linear equation, we get one value of x which satisfies this equation. But in case of inequality, the value of x is not unique. Like if I put x is equal to 1, 1 plus 2 is less than 3, inequality is satisfied. If I put x is equal to 0, 0 plus 2, 2 is less than 4, inequality is less satisfied. If I put x is equal to minus 1 plus 2 is equal to 1, which is less than 4, again inequality is satisfied. What does that mean? All those values of x which are less than 2 are solutions of this inequality. And how do we represent that solution? We represent that solution on number line. Actually, this is the solution which gives you x should be less than 2. Any value less than 2 will satisfy this equation. And on real line then, this is the real line. See over here, I have a real line x representing x. This is the real line. This is the mean position 0. This is 1. This is 2. This is 3. This is 4 and so on. And on the other side, this is minus 1. This is minus 2. This is minus 3. This is minus 4. So what are the solutions? X is less than 2. This is x2. Any value on the left hand side of this line is less than 2. So this is the solution, graphical solution of this linear inequality. This will be a hole over here if equal to sign is not included. If the inequality is like this, x plus 2 is less than or equal to 4, then we write x is less than equal to 2. Then this hole will be filled and this will be a dot, then a hole instead of a hole. So this is solution of this inequality. So we generally represent the solution of any linear inequality in one variable on a real line with the help of this graph. We plot it like this. Let us solve few questions regarding this. Plotting the number line. For example, I have an inequality 3x, x is less than equal to 2, or x is less than 2, or x is greater than equal to 2, or x is greater than 2. So how will I represent these inequality on real line? This is our mean value 0, this is 1, this is 2, this is 3. Likewise, this is minus 1, minus 2, minus 3 and so on. First, we have to plot all those values which are less than or equal to 2. 2 is included. So this graph will be like this. It will be a dot and less than 2 will be indicated in this direction. Second is as x is less than 2. It will be a hole on 2 and then we will represent this inequality. And what is x greater than equal to 2? It will be a dot on 2 and solutions will be all those values which are greater than 2. And x greater than 2, it will be a hole on 2 and solution will be all those values which are greater than 2. This is how we represent any inequality on number line. So far we have just learned few arithmetics which we can perform on any linear inequality. I recall, we can add any positive number, we can subtract any positive number from both sides, we can multiply the inequality on both sides with any positive number, we can divide by any positive number, we can multiply with any negative number on both sides, but by doing that the inequality will be reversed. Less than sign or less than or equal to sign will be converted to greater than or greater than and equal to sign accordingly. To wind up today's discussion, let us solve few questions. Question number 1. We have to solve this linear inequality and then we have to present the solution on the number line. What is the inequality? 6 minus 4x is greater than equal to 18. Dear student, first of all, what we have to do, we have to take the x on one side. Here, practically, what will I do? I will add minus 6 on both sides. What will this minus 6 do? It will cancel out with 6 and we will be left with minus 4 is greater than equal to 18 minus 6 is equal to 12. This is our first target in solving any inequality. We have to remove any constant on the side of x so that only x remains there. In next step, we will remove this negative 4. This is minus 4 which is being multiplied with x. So how can we remove this? We can divide by minus 4 on both sides. By doing so, this inequality will be, yes, it will be reversed. Because by multiplying or by dividing with a negative number, inequality is reversed. So we are left with only x is less than equal to 12 over 4 is minus 3. So this is the solution of the inequality given to us. Now we have to present this solution on number line. This is the number line. Let me have a rough sketch. This is 0, this is 1, minus 1, this is minus 2, this is minus 3, plus 1, plus 2, plus 3. This number line looks like this. So what we have to do is this, there is an equality sign? Yes. So on 3, minus 3, there will be a dot instead of a hole. And we have to highlight all those values which are less than minus 3. Less than minus 3 means we will move towards left. So this is the solution to this question. This step can be directly jumped to this if we solve 6 minus 4x is greater than equal to 18. I will just move this 6 over here like we did in equations. This can be written directly like this. Instead of subtracting minus 6 on both sides, we can directly do this. And then we can multiply with minus 4. Divide by minus 4. I hope this is clear. Let us move to our next question. Solve the inequality. Again, we are given an inequality. We have to present the answer in our number line. Inequality is 3x minus 4 is less than 18 plus x. First of all, 3x minus x is less than 18 plus 4. I hope you understand. I have moved this minus 4 to the other side. It will become plus 4. It is just like adding plus 4 on both sides. I have moved this plus x to this side and this will be minus x. So we will rapidly solve 2x is less than equal to 22. Now what we have to do? We have to get rid of this 2. For that we will divide both sides by 2. 2x is less than equal to 22 over 2. X is less than equal to 11. Now we come to number line. 0, 5, 10, 15. This will be 11, minus 5, minus 10, minus 15. Sign is less than or equal. Equal to is means this is inclusive case. There will be whole dot on 11 and we will move towards left hand side because inequality is less than or equal to. So these all values which are less than 11 are solution of including 11. I hope this is clear. Our next question. We have to solve this inequality. Again, we have to present the answer in number line. Inequality is 2x plus 5 is less than equal to 1 minus x. 2x plus x is less than equal to 1 minus 5. Is that clear? 3x is less than minus 4. 3x over 3 is less than equal to x is less than equal to minus 1.33. So please do it by yourself. You can plot it on the number line. A bit different question. Write down all integers that satisfy this inequality. Minus 6 is less than equal to 3x is less than equal to 6. What is this 3? Coefficient of x. We will divide the inequality by 3. Division by positive number does not change the inequality. Minus 2 is less than equal to x is less than equal to 2. X, minimum value of x is minus 2, maximum value of x is plus 2, both are included. So possible integral values will be integral values. It will be minus 2, minus 1, 0, 1 and 2. This is the answer to this question. Bit different question. To wind up this today's lesson, find the smallest integer n such that 3n is greater than minus 17. 3n is greater than minus 17. First step, 3n over 3 is greater than minus 17 over 3. N is greater than minus 5.66. N should be greater than this. So what are the values greater than this minus 5? Minus 5, minus 6, minus 4, minus 3, minus 2, minus 1, 0 and so on. We have to find the smallest of these, which is minus 5. Least possible value, possible integral value is equal to minus 5. I hope this is clear. There is another question. Find one value of x that satisfy this inequality and this inequality. Now we are given two inequalities. X is greater than 4. It is already in the simplest form. 17 minus 4x is greater than 2 minus x. We have to simplify this one. Can I write 17 minus 2 is greater than 4x minus x? 15 is greater than 3x, or I can write 3x is less than 15, or x is less than 5. On the other side, x is greater than 4. We have to give one possible value of x which satisfies this and this both. It means x is less than 5, but x is greater than 4. So value can be 4.1, it can be 4.2, it can be 4.3. It should be less than 5 and greater than 4. But you only have to give one possible value. Dear student, this was today's lesson, inequality. We learned to solve, simplify the inequality and draw its graph on number line. In next lesson, inshallah, we will move towards solving the linear inequalities in two variables and ultimately move towards linear programming. I hope you have enjoyed today's topic. Please do subscribe the channel, like and share it with your friends. Keep watching. Allah Hafiz.